Okay, we did cover we did cover the first part of integration last time, but I decided to start the integration because we only covered the first small part, so I will go back to it again. Again, after this video or after this class, you should know how to explain the concepts of integration as the reverse of differentiation, and you need to explain how to use the power rule, apply the power rule into an integral given the composite functions, and we'll add the substitution and the concept of definite integral and the area under the curve. Okay, again, what you did with Prof was a differentiation, right? Which represent the change. So you were just doing the change. You learn how to differentiate and what does it mean and how to apply it. So today we'll study the integration, which is the reverse process of the differentiation, meaning the integration is the inverse of differentiation. Like, sometimes we encounter operations which are a reverse process of each other. Like, for example, we have addition, which is the reverse process of differentiation, and we have multiplication as the reverse process of division. So this is it here. Please, can we have someone to admit those who are in low, because I can't see them. Okay. In similar way here, the integration is the reverse process of differentiation. Okay, this means when a function, let's say you are given a function, f at x is equal to x squared. Remember, if you differentiate this function, if you're asked to differentiate this function, you'll have f prime at x is equal to 2x, right? Then when we integrate the results, these results, you should go back to here, to the original function. That's why we say the integration is the reverse process of differentiation.
So, yes. Sorry, ma'am, your screen is not showing. I think you've already started to do that calculation. We're still seeing that topic, the integration theory. I'm not so sure that it's only me or the whole class. We're not seeing your working now as you're explaining.
Can we try again?
It was showing on my side.
So showing, I think she had a problem with network or something. Okay, thank you. Is it still showing?
Yeah, it's showing.
It's showing.
All right, thank you. Okay.
I'm sorry, guys.
If we are asked to differentiate, okay, to integrate f prime at x with respect to x, which is this result, which is the differentiation of this function. Ne? If we are asked to integrate it, meaning we said f prime at x is equal to 2x, right? And we are asked to integrate 2x with respect to x. Since we said the integration is the reverse process of differentiation, meaning since this function is the derivative of this function, if we integrate this derivative, we should get the original function. Meaning, if we integrate this, we should get x squared, which is f of x, right? Okay. Again, this sign means integration. It's a symbol for integration. And this dx, it means you are integrating with respect to x. Okay, again, if we have f at x and we differentiate f of x with respect to x, you will get f prime at x, right? And if you have f prime at x, you integrate that f prime of x, you should get f at x. Okay? And this process is called integration. Integrate. Okay, and if we move here to here, this process is called differentiation, meaning we are differentiating. Okay, as in differentiation, we have rules, right? So even in integration, we do have rules of integration. Okay, remember in differentiation, you started with a power rule. So we do have a power rule in integration too, which is the power rule is the reverse process of the power rule in differentiation. Né? The power rule for integration is a reverse process form, or you can just say it's an inverse of the power rule for differentiation. Right? We have integration rules. And the first rule is the power rule, which is just the basic rule for integration. The power rule for integration. Okay. Remember, if you differentiate, let's say, a function, if you differentiate maybe a function, you are given a function f at x is equal to x cubed. Remember, if you differentiate this by power rule, you will have f prime at x as the derivative of x cubed with respect to x, right? And the derivative of x cubed with respect to x would be 3 times x to the power 3 minus 1, which is just 3x squared, right? This is what Prof did with you. And we call this rule that we used here the power rule for differentiation. Okay, remember I said the power rule for integration is the reverse process for power rule for differentiation, right? So what we did here, okay, first to apply the integration, the power rule for integration, meaning we have to move from here. We want to integrate this to get this, right? Meaning, okay, let's first compare these two powers. We have x cubed and we have 3x squared, right? You see, we have 2 and we have 3, right? Meaning we have to add 1 to the exponent to get to this exponent, right? And this exponent it's 1 times x cubed, and this one it's 3 times x squared, right? Meaning after adding 1, we then have to divide with 3 to move here to here, like to move from 3 to 1, right? Remember, I said the reverse process for addition is subtraction, right? Since here, this is 1 minus this, meaning if you want to move from here to here, you'll have to add that 1, right? And we said the division is a reverse process for multiplication. Since we have 3 times this, To move from here, we have to do the reverse process of multiplication, which is division, meaning we have to divide by this 3 to move from here to here, right? Okay, this means the integral of f prime at x with respect to x would be, okay, we said the integral of, okay, the integral of f prime at x, we said f prime at x is 3x squared, right? And we are integrating with respect to x. Remember, we said to move from here to here, we first have to divide by 3. Okay, we said we'll divide by 3 and we'll add 1 here, meaning this would be, we have, okay, initially we had 3x squared, né? And we said we'll add 1 and we'll divide by 3. And if you simplify this, this would be x cubed, right? Which is our original function, which is f at x. Now, suppose we want to differentiate, to integrate another function. Let's say we are given f at x now as x to the power 10, right? Okay, this means we should find a function whose derivative is x to the power 10, right? And we know that if f at x is this, then f prime at x is the same thing as the derivative of x to the power 11, right? If, okay, let me just say, oh, it's x to the power 10, right? And if we differentiate x to the power 10, you will get 10x to the power 9, right? And again, if we are asked to integrate this function, meaning you should get this function, since the integration is the reverse process of differentiation, right? Okay, to get here, you see, we have to add 1 here and we divide by 10, right? Which means this function is 10 times this function. And the exponent here is -1 times that exponent, yeah, for if original function, right? So again, this means we have to add 1 here, we divide by 10. So this means the integral of 10x to the power 9 with respect to x is equal to, okay, we add 1, we divide by 10, is equal to x to the power 10, right? Are we still together? Okay, I guess we don't have questions. Okay. If we differentiate these, we get this, and if we integrate this, we get back to the original equation, right? But we know that the derivative of a constant is 0, right? This means our answer might be wrong because there might have been a constant here, right? Because let's say you are asked to differentiate, okay, x, okay, your f at x is x to the power 4, plus 5, and the other one, f at x, is x to the power 4 plus 10, and the other one, f at x, is x to the power 4 minus 10. If we differentiate this, okay, you'll get f prime at x is equal to 4x cubed, right? And if f at x is this function, then you will get f prime at x is equal to 4x cubed again, which is the same as that one, right? Again, if we differentiate this function, you will still get f prime at x is equal to 4x cubed, right? Meaning, in this, from these functions that we integrated, there must have been a constant too, which you didn't know. Because remember, the integration is a reverse process for differentiation, right? Let's say meaning if you integrate this, you should get this, right? But this means, what if we, okay, now the question is, what if we had a constant here like this? We have 5, but if we integrate this, we get, this means we'll get this, right? Now, what if we had 10 as a constant? Now, what is the way forward? What, ne? Meaning, we must add a constant of integration, because if you differentiate a constant, you will get 0. Meaning, in all the functions that we integrate, we need to add a constant, which is called a constant of integration. Okay, in this module, we'll represent that constant with C. But in other books, they do use other constant. But as long as the constant is added at the end of the integration, meaning that constant is called the constant of integration. Okay, for example, if let's say you are asked to integrate 3x squared dx, remember, you need to add 1 here, right? Meaning we have 2 plus 1. Remember, we still have this 3, and then you divide by 3. Now, what I'm saying is you need to add some constant here to show that that function maybe had a constant. The original function had a constant. Okay? Meaning here, this would be x cubed plus c, right? And on the first one, the one that we integrated, which is x to the power 10 dx, meaning this one must be x to the power 11 over 11 plus c. And this plus c represent the constant of integration. Ne? So this means in generally, the power rule for integration would be given as the derivative, x to the power n dx. If you are asked to integrate this, then your after integrating, yes.
Like, what's the significance of adding the c? Why do we have to always add the c?
Because we are trying to go back to the original function, right? And we are not sure whether the original function had a constant or it didn't have a constant. If it didn't have a constant, then you assume c is 0.
Okay, I understand.
Right. So in generally, if you're integrating x to the power n, meaning we have to use a power rule for integration. Then if you use a power rule for integration, you'll have x to the power n plus 1. You add 1, then you'll divide by a new exponent, which is now n plus 1. Then you'll add your constant at the end. That's why, okay, let's go back to this one. There we had 3x squared dx, right? Meaning our n here was 2. And if our n here was 2 and we apply this rule, meaning we have 3x to the power 2 plus 1. Remember, you divide by n plus 1. N plus 1, okay, which is 2 plus 1, then plus c. And if you simplify this further, you have 3x cubed over 3 plus c. And this 3 will cancel out and we'll have x cubed plus c, which is this.
Hi, ma'am.
Yes.
Can I take you back? Just go up. Where there's 11, if I'm not mistaken. Oh no, just go down a bit. Just stop there.
Okay.
There's a part where I'm looking for oh yeah, this one. I had load shedding, so I missed when you were explaining this part. How did we end up with the 9 plus 1 there at the top? Because I see 9. Okay. I thought this was it's 9.
It's 9.
See, it's okay. Now I see where the 9 comes from. All right. No, it's fine then.
Yeah. Okay. And again, this rule only applies where n is not equal, does not equal to minus 1. Okay, let me add here. Only where n does not equal to minus 1. So we can only use this rule whereby n does not equal to minus 1, meaning n, we can use it when n is equal to 1, where n is equal to minus 2, where n is equal to 2, where n is equal to minus 100. You can still use it as long as n does not equal to minus 1. I will give you another rule to use where n is equal to minus 1. Okay. We have other rules for integration, like in differentiation again. We have we have that rule saying the integral of a constant, let's say we are asked to integrate a constant, right? The integral of a constant will
Maria, please mute. Maria, please mute.
Yeah, I'm trying to do so.
Okay.
Let's say we are asked to integrate a constant k. Ne? The integral of a constant k, let's say we're integrating k with respect to x, will always be kx. Ne? Then remember, we have to add a constant of integration, which is this c. So for example, let's say we are asked to integrate 5 with respect to x. That means the integral of 5 with respect to x would be 5x plus c, right? Remember, again, please take us back to the fact that the integration is a reverse process of differentiation. Remember, if we have f at x is equal to 5x plus c, and we are asked to find the derivative of this, this means the derivative of this would be just 5, right? Because if we differentiate 5x, then you get 5. And if we differentiate the constant, you get 0, right? Meaning if we integrate this 5, we should go back to here. That's why if we differentiate a constant, if you integrate a constant, let's say with respect to x, then you'll multiply that constant with x, then you add a constant of integration. Again, if let's say you were integrating a constant with respect to y, let's say we are asked to integrate 10 with respect to y, then the integral here would be 10y plus a constant of integration. So this is another rule for integration. Are we still all together? Okay. Pardon?
Oh yes, I wanted to make a request that once you're done explaining all the rules, if we can do the activities on the study guide, because I see some have a square root and we haven't done any example that has a square root. That is confusing for me.
All right. And okay, remember we have this rule, and it's exponential rule, meaning any number besides 0 raised to the power 0 is equal to 1, right? And I said the derivative of a constant is the integral of a constant with respect to x is equal to the constant times x. Again, suppose we asked to integrate k with respect to x. This is the same thing as in the integral of 1 times k with respect to x. Remember, anything multiplied by 1, you'll get that same thing, right? Meaning if we multiply k by 1, we still have k, right? And again, we said x to the power 0 is equal to 1, right? Meaning where there is x, we can substitute x by x to the power 0, and we will have k times x to the power 0, right? We still have this dx. And if you want to apply the power rule for integration here, meaning this will give us, okay, let's take this k out. This will give us, we have 0, we said, this is our power rule. We said we'll add 1 to the exponent to your n, and then we'll divide by n plus 1. Meaning in this example, our n is equal to 0. Meaning we have 0 plus 1 over 0 plus 1 plus the constant of integration, right? Meaning we have k to the power, k times x to the power 1 divided by 1 plus c. And this gives us kx plus c, right? Remember, I said if we integrate the constant with respect to x, that means you have the integral would be k times x plus a constant of integration, which is this. Are we still all together?
Yes.
Okay, then we
Yes,
have
ma'am.
again, thank you, the integral of a constant. Né? If, let's say, you have a constant multiplying a variable or a function, it's okay to take that constant out before you integrate, right? Meaning, if you are told that k is a constant, né? And we are asked to integrate k times f at x with respect to x. Since this k we are told is a constant, meaning we can take out this k before we integrate. Né? Then we'll do this integration. Then the final answer would be the integral here times this k as a constant, right? Meaning, again, if let's say you were integrating, okay, let me go back to, if let's say your k is equal to 10 and you are integrating 10, maybe 10x, the x, né? Then it's safe to take out this 10 before you integrate, right? And okay, let's say we continue with this integration. This means our answer would be 10 into, then you can apply the power rule for integration here. And if you apply your power rule, you see your power is 1, meaning your n is 1. Meaning you have x to the power 1 plus 1 over 1 plus 1 plus the constant of integration, right? And this would be 10 times x to the power 2 over 2 plus c, which will give you 5x squared plus c. We don't have questions, right? Or do we?
I do still have that request. I didn't get an answer if we were gonna do them or not, Ms. Nolas.
I do the exercises and the examples. Okay.
Oh,
At least.
one with that have got square roots.
I will do it.
Oh, okay.
Okay. Then we have a rule for sum, integral of the sum of number of tens. For example, let's say we are integrating f of x plus g of x, meaning we have sum of two functions, right? Which is f at x and g at x. If we are integrating this, it is safe to separate them, right? Meaning the integral of this, of f at x with respect to x. Okay, meaning you can integrate them separately and add them at the end, meaning the integral of f at x would be, integral of f at x plus g at x would be the integral of f at x with respect to x plus the integral of g at x with respect to x, right? And this is the integral of the sum of number of tens, okay? And we have the fourth rule. Okay, the fourth rule is from, it would be the rule of logarithm. Okay, we know that if we differentiate ln x, we get 1 over x, right? Meaning if we integrate this, you should go back to this. You see, 1 over x is the same thing as x to the power minus 1, right? Remember, I said the power rule only applies when n is not equal to minus 1. Now, if n is equal to minus 1, it's okay, meaning we have 1 over x, and we know that 1 over x was, okay, you get 1 over x if you differentiate ln x, meaning if we integrate this, we should go back to ln x, to that, right? This means the integral of x to the power minus 1, or just the integral of 1 over x dx is the same thing as ln x plus c, because it's the integral of this plus the constant of integration. Now, okay, remember for integration, if we are asked to differentiate, let's say ln 2x, ln 2x will give you 2 over x, right? If we are integrating 2x, you'll get 2 over x, right? Meaning, if we integrate this, you should get this, right? Okay. Meaning, if we integrate 2 over x dx, you should get ln 2x, right? Oh, I did something wrong here. Sorry. I'm sorry, I think I did something wrong there. If we differentiating, it doesn't want to write anymore. I don't know, how did I get to this pen? Just a second. Okay. Let's say now if our f at x, for example, was 2 ln x. Right? Now, if we differentiate this, then means you'll get e over dx to ln x, meaning you'll have 2 over x, right? Because you can take out this constant and you'll have, okay, if you take out the constant here, you'll have 2, the derivative of ln x. And we know that the derivative of ln x is 1 over x. Then we have 1 over x times these 2, right? Again, an example like this. Okay, let's say we are asked to differentiate, ln x squared. The derivative of this would be 1 over x squared times 2x, which is the same thing as 1 over x, or as 2 over x, right? Because this x and x will cancel out. Okay, first, did you use substitution here under the differentiation? Yes, no.
We are lost.
Okay, let's leave this part for now.
Sorry, is it the one where we substitute, where we use u and v?
No, that's another one. Okay, we'll get here. For now, let's have this, that if we integrate 1 over x, you get ln x. Okay? We'll do this one when we get to substitution. I think this is the best, thingy. It's not a correct example for this rule. Okay, I think for this rule, we'll end here. Okay, then we have another rule for natural exponential function. Meaning, remember, if you are differentiating e to the power x, you get e to the power x, right? Meaning, if we integrate e to the power x, again, you should go back to e to the power x, right? Meaning the integral here would be e to the power x plus a constant of integration. Please don't forget to add the constant of integration at the end. Yeah? Are we still all together? Yes, no?
Yes.
Okay. Now, I gave you 5 rules, right? Let's try and do examples applying all these rules. Okay. Example 1. Suppose we are asked to find the integral of f at x is equal to x cubed plus 10x plus 1 over x plus e to the power 3x plus 15. Now, don't just check the function and assume you're asked to find a differentiation. Now, here I said we should find the integral, even though I'm giving you the function as f of x, not as f prime of x. Yeah. Okay, if we are asked to find the integral for this function with respect to x, meaning the first step is to write the integral sign, meaning to show that you are integrating the integral of f at x with respect to x, right? and this will give you x cubed plus 10x plus 1 over x plus e to the power 3x. Okay. Let's remove this 3. We'll use it on under the substitution. I'm not going to add this 3, just e to the power x plus 15, right? Dx. I said you can separate all your terms, right? Remember, we have the rule for some of the terms, right? I said the integral of f at x plus g at x with respect to x, you can separate them and integrate them separately. So the first thing that we need to do is to apply this rule to make we are trying to simplify our function. Yeah? In fact, we are trying to avoid what these errors is. Meaning if we separate this, we'll have the integral of x cubed dx plus 10x dx plus 1 over x dx plus the integral of e to the power x dx plus the integral of 15 dx, right? Now it's simplified. You see, then you check which rule can you apply in each term. You see here, we are integrating x cubed with respect to x, meaning we have a power function, né? Meaning we can apply the power rule here for integration. Remember the power rule, you add 1 to an exponent and you divide by a new exponent. Meaning here, your n, which is your exponent, is 3. Then the answer here would be x to the power 3 plus 1 over 3 plus 1, right? Do we agree with this one?
Yes.
Okay. Then you have plus 10, there's 10. Remember, the other rule is to take out the constant from the integration if you do want to, but you can integrate while the constant is inside the integration. Yeah. So we have x, just x, we're integrating x with respect to x, with respect to dx. You see here, the power is not -1, is 1, right? Meaning we can use the power rule, right? And if we use the power rule, this will give us x to the power 1 plus 1, because the power here is 1, meaning n is 1. So we have n as 1 plus this one that we'll add, then we divide by this, which is 1 plus 1, right? Then plus, and we said we have, then we said if our n is equal to -1, okay, first we said 1 over x is the same thing as x to the power -1, meaning the n here is equal to -1. If n is equal to -1, then this means the integral of this would be ln x, né? So this means here we have ln x, we'll get ln x if we integrate 1 over x, né? Then we move to e to the power x. We said if we differentiate e to the power x, you get e to the power x, meaning, again, if you integrate e to the power x, you should go back to e to the power x, right? Because e to the power x doesn't change, meaning this term will give us e to the power x, right? And we have the integral of 15 with respect to x. Remember, I said if you are integrating any constant with respect to x, then your integral would be that constant times x, right? So here we'll have 15x, right? Okay. You see, we have integrated all the terms, but we don't have the constant of integration, meaning we need to add the constant of integration. Remember, you add the constant of integration after integrating. Since we have integrated all our terms, meaning we have to add the constant of integration now. Okay. So this means, okay, then the next step is to simplify your function. And if we do that, we'll have x to the power 4 over 4 plus 10 times x squared over 2 times ln x plus e to the power x plus 15x plus c. But we are not done with simplifying function further. Then, meaning our final answer will be x to the power 4 over 4 plus 5x squared plus ln x plus e to the power x plus 15x plus c, which is the constant of integration. Do we have questions so far?
The 5, did we divide 10 by 2?
Yes.
And then please just explain the ln x and the ex, why the ex doesn't change, and the ln x. If you can just explain that again.
Remember, if you integrate, you are trying to go back to that function that was differentiated, right?
Yes.
And we said if you are given f at x is equal to e to the power x, this means the derivative of, we have this rule, the derivative of e to the power x remains the same, right? E to the power x, right? Meaning, okay, and we said if we integrate f prime at x with respect to x, we should get f at x, right? And our f prime in this case is e to the power x. And our f at x in this case is e to the power x, right?
Okay.
It doesn't change. E to the power x doesn't change. And ln x, we said if your f at x is equal to ln x, and if we differentiate ln x, you get 1 over x, right? Meaning, if you integrate this, you should go back to this. So whenever you see the integral of this, just write this. That's the rule.
Okay, last question. You said we don't add 1 only if it is -1. So I just wanted to know, is it limited to -1, or even if it is -2 or any negative number?
Just -1.
So if it's -2, you can add 1.
Look, if you are given f at x is equal to x to the power -2, the derivative of this function would be minus 3 e to the power minus, is it -3, right? And if you integrate this, you should go back to this.
Okay, the reason why
this is -2, this is -2, I'm sorry, this is -2, but here it's -3.
The reason we don't add 1 when it's sorry, when it is -1, is it because it will give us a 0?
Yes.
We are avoiding to get a 0.
Yes.
Okay, thank you.
You just have to get that original function you differentiated.
All right, it's clear. Thanks.
Okay, if you are given a function and you integrate it to check if your answer is correct, you can just differentiate that answer to check if it's correct. And if you are given a function and you are asked to differentiate it, and if you are not sure about your answer, you can integrate your answer to check if you'll go back to that function you were given. Ne? Again, if you integrate, if you are given a function to integrate, you are not sure about your answer, just differentiate your answer to check if you'll get the same function you were given. You are asked to work on. Is it clear now? Okay, let's try and do
Yes.
another example. Let's say we are asked to integrate 10 x to the power 4 plus root x minus 1 over x cubed plus 3 over x plus, let's say, hundreds. Okay. Say we are asked to integrate, to find the integral of this function, meaning you are asked to integrate this function, right? Okay, and if we integrate this function, okay, write the integral sign to show that we are integrating with respect to which variable. Meaning we'll have the integral of 10 x to the power 4 plus root x minus 1 over x cubed plus 3 over x plus 100. We are integrating everything with respect to x. Okay. And I said the first thing that you can do is to separate all your terms, like to integrate them separately. And you can have 10, you can write this as 10 times the integral of 4, okay, x to the power 4 with respect to x plus the integral of root x with respect to x minus the integral of 1 over x cubed with respect to x plus 3 times the integral of 1 over x dx plus the integral of hundreds with respect to x, right? And then before you integrate, you can check if you can simplify your function further before you can even integrate, just to make it simple for you to apply your rules. Ne? Okay, we have 10, the integral of x to the power 4 dx, then plus, we have square roots of, we have root x with respect to x. You can write root x as x to the power a half, right?
Why are we saying half?
Because it's a square root.
Oh, okay, okay.
Because if you have something like this, f to the power a half is the same thing as root x, right? This is the same thing as in if you have, let's say, m root x to the power n. This is the same thing as x to the power n over m. Ne? And in this case, our n was 1 and our m was 2. And we know that the square roots represent 2. So, and we said our n is equal to 1 in this case. And we know that if a variable doesn't have a power on top, it does, meaning the power is 1, right? So if you have something like this, you can write it like this, as in, if you have something as in maybe 3, just cube root of x, meaning you can write this as 1 over 3. We said if there is no power here, meaning the power is 1. Are we all on the same page?
I'm following.
Okay, we have then we are in this on this term right now. This term we can write it as x to the power minus 3 dx plus 3 1 over x dx plus 100 dx, right? You see, now it would be easy for us to apply our power rule because we can't simplify this function further. So after noticing that you can't simplify your function further, then you can apply your rules on that function. Okay. And if we apply our rules here, we'll have 10. Okay, here you see we are integrating x to the power 4, meaning we have a power function, meaning we have to apply the power rule, right? For power rule, we said you'll add 1 to your n, and our n is 4 here, and then you divide by the with that new power, and our new power is x to the, it is 4 plus 1, right? Again, here we have half, x to the power a half, meaning we have a power function, and you see this power is not minus 1, né? Meaning we can use our power rule, and the power rule says you have to add 1 to your exponent, and then you divide by a new power, which is now half plus 1. Yeah? And we have minus, okay, we have x to the power minus 3. This is a power function, meaning we need to apply our power rule. And this, okay, the power is not minus 1, it's minus 3, meaning we can use our power rule here, right? So this means the integral of this would be x to the power minus 3 plus 1 divided by minus 3 plus 1. Yeah? And this is 1 over x. 1 over x is the same thing as x to the power minus 1. Yeah? Meaning n here is minus 1, meaning we can't use the power rule. But we know that the integral of 1 over x is equal to ln x. Ne? Meaning if we integrate this, we'll have ln x. Then we have 100. We have the integral of 100 with respect to x, and 100 is a constant. And we said the derivative of a constant with respect to x would be that constant times x. So meaning we have plus 100x. Okay. We are done integrating all the terms. After integrating all the terms, remember to add the constant of integration. Yeah? And then you simplify your functions, all your terms. We have 10 times x to the power 5 over 5 plus x to the power, this is 3 over 2, right? Over 3 over 2 minus x to the power minus 2, because we have minus 3 plus 1, which is minus 2, over minus 3 plus 1 is minus 2, right? Then plus 3 ln x plus 100x plus c. Okay, you see, we can still simplify this function further. And if we do that, we have 10 divided by 5, and that will give us 2x to the power 5. And we have x to the power 3 over 2 divided by 3 over 2. And we can write this as 2 over 3 x to the power 3 over 2, right? And we have this divided by minus 2, meaning we have minus divided by minus, that is plus, right? Meaning we can write this as 1 over 2
So please explain the 2 over 3 times x 3 over 2. I don't understand.
what?
I'll say please explain the 2 over 3 times x to the power 3 over 2. How did the number swap around?
Okay, it's like we have a over over 5, right? You know a over 5 is the same thing as a divided by 5 over 1. Because 5 divided by 1 is the same thing as 5, right? Meaning, and okay. Please mute your mic. And we said the division is the reverse process for multiplication. Meaning, if you want to cancel this division, you can just multiply with the inverse. And the inverse of 5 is 1 over 5, right? So, meaning to cancel this, we can just put the multiplication and the inverse of this, meaning this would be a times 1 over 5, right? And that side we have x over 3 over 2, meaning this is the same thing as x divided by 3 over 2, right? And I said to cancel the division, you can put the multiplication and multiply by the inverse of what you were going to divide with. Meaning if we cancel this, we put multiplication, then we have to do the reciprocal of this. Meaning this would be x times 2 over 3. You just swap the denominator and the numerator.
On the x, we still have the 3 over 2. It's x to the power 3 over 2 divide 3 over 2. Meaning here on the x, there's 3 over 2 as well.
You see, here we still have a, and here we had a. Here we still have x, and here we have x. Meaning, if we have x to the power n divided by 3 over 2, this would give us x to the power n times, okay, first divide by 3 over 2, which is the same thing as n, x to the power n times 2 over 3. That's why we still have 3 over 2 here, because the numerator doesn't change, it remains the same. it won't be affected by changing the operation here. Because remember, it's the denominator only that would be affected by your operator operation sign. Yes.
Okay, I understand.
You sure?
Yeah.
Okay, do we have any questions on this example that we did? Yes, no? Yeah. Oh, then there was a person who asked me to do this one with the square root. Do you understand now? Yes, no? Are you still here? Okay, guys, please on your spare time, please find the integral of this. Ne? And oh yeah. And if you find the integral of this, you should get ln x plus 5/2 plus c. So please work on this and try to get this as your solution. Okay, you should get this as your solution. Do we have any more questions? Yes, no? Are you guys still there?
Yes, ma'am.
We still
Sorry, ma'am.
Yes. Okay, guys, let's move on to our next rule, which is integration by substitution, which is, okay, this is the reverse process of the differentiation by substitution, where we use du, we replace x dx with u du. Ne? Okay. I think you use the word chain rule. Yeah, I think you use chain rule because it's the same thing as the integration. They use substitution for differentiation. So it's either you use chain rule or you say use substitution for differentiation. I'm not sure which term did you use, but this is the reverse process of what you did there in the differentiation. Ne? Let's say, for example, we are given f of x is equal to 10x plus 30 to the power 10. Ne? Hey, and we are asked to differentiate this function. We know it's not easy to use the power rule for differentiation here to differentiate this function. Meaning we have to introduce another variable. Now, let's say we introduce the variable u. Say we let u to be 10x plus 30. Okay. Now, meaning our new function is f of u is equal to, okay, we said this is u, right? Is equal to u to the power 10, right? Meaning if we are asked to integrate this term, it's like, okay, we are asked to integrate u to the power 10 with respect to u, right? And if we are asked to integrate a term like this, okay, if our function is now like this, it's like u to the power 10, meaning it would be easy for us to use the power rule for integration, né? And if we use the power rule for integration here, you get u to the power 11 over 11 plus 10, right? Because you add 1, then you divide with the new power. But we're not given our function as in u. We are asked to integrate a function with respect to x, né? Meaning you have to take into account of the inner function, which in this case is 10x plus 30. Ne? So, meaning you can't just substitute, okay, initially your term is like this, integral of 10x plus 30 to the power 10 with respect to x. You can't just substitute this dx with du, né? Without proving that they are equal. Okay. We need to solve for du again before we even substitute here. Né? Okay, let's try and do that. If we let u to be 10x plus 30. Okay, since this function is now the function of u with respect to x, meaning to get du, we need to differentiate this function with respect to x. And if we differentiate this function with respect to x, we get 10, right? Then from here, we can solve for du. So that we'll know that whether du does equal to dx or not. Ne? And if we solve for du here, we should obtain du. We will obtain du is equal to 10 dx. Ne? Then, yeah, we'll get 10 dx. Ne? But here, our original function doesn't have 10 dx. It has dx. So this means dx is equal to du over 10. So where we see dx, we can't just substitute dx with du without solving, without knowing, without proving that they are equal. And now, after trying to prove if they are equal, we notice that dx is equal to du over 10. So we go back to our equation where we see dx, we'll substitute dx with du over 10, right? Meaning our new integral, okay, initially we have 10x plus 13 to the power 10 dx, and we said this is u, right? So this is u to the power 10, and we said dx is equal to du over 10. So this means our new term would be du over 10. And remember, we said we can take out the constant before integration, meaning this is 1 over 10, the integral of u to the power 10 du. And we said if we integrate this, we will get u to the power 11 over 11 plus the constant of integration. and this is u to the power 11 over 10 times 11 is 110 plus a constant of integration. Then after finding after integrating, we can now substitute our u back, because we assumed our u to be equal to 10x plus 30. So at the end, you can just substitute your u back. So this means this integral is equal to 10x plus 30 to the power 11 over 110 plus a constant of integration. Right? Do we have questions? Yes, no.
Yes, please. Can you move the screen up? I want to find out how did we get the 1 over 10? Down, slightly down.
The 1 over 10?
Yeah, the 1 over 10 in bracket du to the power 11 over 11.
This 1 over 10?
The one over 10.
It's this 1 over 10.
Yeah, no, the other one.
It's this one.
The bottom one. The 1 over 10.
You mean this one? Yes.
How did we get it? How was it moved to out of the bracket? For example, I don't know how to put the question.
Because we were using, I think it's rule 2. Was it rule 2? Where I said you can take out the constant outside the integral. Yeah, it's rule 2. It's this rule. If you're integrating a constant times a function, you can take out that constant outside the integral sign. And our constant in this case was 1 over 10.
It's not 10.
Yeah. This is the same thing as 1 over 10 u to the power 10 du. And then I took this outside the integral sign.
Okay, thank you.
Because we are out of time, we're out of time. Next time on our next section, I think I'll start from here and use substitution. But please go and check it on your study guide, because that's where we'll start. Then we'll do the definite integral and the area under the curve. I'm not sure whether we'll be able to cover the application or we'll cover the application next week. Okay, guys, since we don't have time, I think we should end here unless you have questions. Do we have questions?
Yes, ma'am, I do have a question.
Yes.
I know we are not yet there at the application of integration, but I'm struggling with this last chapter when it comes to consumer and producer surplus.
I can't cover that right now. I don't want to confuse other students, but
Okay.